Hi, I'm John Dawson with ExactData. I'm here with Tom Hager, one of our senior engineers, Todd Johnson. Todd, you want to say hello? And also Prince Levy with Grant Leading Technologies. We're a technology company, and we typically work with integrators and to do all the things we don't do well. And that's Prince. If Prince can say hello.
Hi, I'm Prince Levy, President and CEO of Grant Leading Technology.
Great, thank you. So what we've got prepared today is a little demo. We're going to get some background about our companies, GLT, Grant Leading Technologies, and ExactData, very briefly, and then get into a demo. Tom's going to be handling the demo. He's actually going to be showing a data model, IMFK2, and then generating some data, and then showing some features of the data. And then we know there's some interest in a GUI. Sometimes people want to actually operate the tool or technology. So we're just going to show a simple example of a GUI. And then Todd and Tom are going to talk a little bit about what a technical approach might look like for actually deploying the technology. With that, Prince, can you tell us a little bit about your company?
Well, thanks, John. Absolutely. Grant Leading Technology, we're a service-disabled veteran-owned small business and 8A company. We specialize in information technology, which is a broad field, of course. However, we do software testing, development. We provide cloud services, as well as project management support, and we create data. And we are also in the asset management space. So we provide services to both federal government as well as commercial customers. So thank you, John, very much.
Yeah, great. Thanks, Prince. I've known Prince a long time. He's just been great to work with, extremely knowledgeable about IRS systems. So he's been a real benefit to work with. A little bit about us. We specialize in synthetic data generation. By that, I mean our data is not derived from production data sources, and that's where we're differentiated in the marketplace. We don't ever touch production data sources. It's fully synthetic. There is no ties back to the production data sources. So there's no privacy or confidentiality issues with the data. We're the market leader in the high end, so high fidelity. And by that, I mean data that actually mirrors the production systems, but again, is fully synthetic. So it's contextually correct. It's statistically valid. It ages correctly over the time axis. It's mirrors the systems of systems across multiple systems. And we do have a very strong patent position in this this technology area also. To our knowledge, there's no competing technologies that we're aware of competing in this space. How we do it, we take requirements, and we'll show, again, we'll demo this, Tom will demo some of this, but we take requirements, we create what's called a data model. And from this data model, it's basically a sophisticated rules-based engine. The tool goes through an iterative process, accessing seed data, so basic data elements, and then it creates a model universe. So it gets all the data correct, and then it outputs it to however the client wants to consume the data. And we'll actually be demonstrating MEF file formats, flat file formats, and image file formats for you today. It's just examples of generating data, synthetic data, being able to configure the data, and then being able to output however the client wants to actually consume the data. We play in multiple different technology spaces. Some examples is IBM. It was a healthcare application for clinical decision support tools. We were creating the medical records that mirrored the PII private information, but didn't. It had specific scenarios into the data. DARPA was a cyber application for host-based sensing, mirroring all the collections that you might make as a corporation and with threats in it. Census 60 systems to systems, very complex project for the last census 2020, very exciting project. Creating the data models and generating data for all those systems with things like fraud scenarios, actually into built into the data for developing and testing very specific systems. Verizon is a commercial project for their creating the data for the Verizon Risk Report product. They were doing weekly software updates, and they had a very difficult time getting the data from their technology partners, and we were able to quickly come in and solve that with some example projects. We've done quite a bit of work at the IRS. We started with a pilot project for performance testing, and we were able to very quickly generate data to mimic peak tax processing volumes. When in the past before us, they were actually duplicating data that they're manually creating with Excel files. Integration testing for EST, performance testing was a CMS ACA project where they're integrating with ACA was first started as integrated with CMS. More EST work. We started getting things like synthetic naps and much higher fidelity in the data that we were creating for the IRS. And specific output file formats such as MEF. And then work with ACA with information returns, and then AIR 7.0 work there also. It's a classic cheaper, better, faster. So again, no privacy security issues. You don't need security clearances. You can transfer the data. No privacy issues. That just all goes away. It tends to be much cheaper. Once the data models are created, you can gen the data at scale for very, very low cost, where with traditional models, you need to actually invest labor as you need data. And this is a scenario where you invest once and then you get return very many. The return on investments are typically very, very attractive with this type of technology at scale. And it's better. It's designed for the system under test. We haven't removed any information from the data. We actually can engineer true and false positives, true and false negatives into the data at scale. It's statistically viable volume, so you can actually start to measure errors. And so you accelerate your development cycle. So you have relevant data immediately that you can quickly configure if it's not the data that you need. With the IRS, we were able to do schema changes, within hours and turn that back around, where with previous methods, it would take months to do that and repopulate their dev environment. So it's a classic cheaper, better factor. With that, I'm going to stop sharing and turn this over to Tom, and we'll do a little demo for you.
Thanks, John. Okay. So as John pointed out, we have created a lot of synthetic data for the IRS, and we've proven capabilities of 1040 tax data with a simulated national accounts profile, et cetera. So today we're going to focus on something a little different: the concept of synthetic data for the IMF and CAID-2 systems supporting the call center. This diagram is simple in scope, easy to understand, but there's more under the hood. We're going to start by creating a simulated nap of filers. Then we're going to create tax data for those, as well as create some transactions. The IMF has hundreds of transaction styles, from bounce checks to changes in filers status, such as death or birth or marriage. And then we're going to do another major focus of this demo is a resume capability. So the filers filed tax forms in 2020. In 2021, we want that same group of filers to be able to file a new year in the life of their income and tax system. So we're going to walk through that. All right. This slide is going to restate it with words. Again, we're creating some tax data for these tax filers. We're going to create some transaction types. The specific ones we're using for the demo are marriage, name change, and move. We're going to generate the next year in the life of these tax filers, and then we're also going to be updating the NAP, showing the transactions, etc. All right, at this moment, I'm showing a particular element of our suite. DDG is not just a tool, it's a suite of tools. And specifically, this one's called Newt. I'm gonna bring it up online. It may not view well to everybody across the internet because this is not a GUI tool, it's a Windows tool. But we'll make the points and then we'll get back to the PowerPoint presentation. So I'm loading up a data model. It'll load up quickly. I'm going to point out a couple of things about the tool. We're going to open up a particular module. We're going to open up a field, and this one's called Filer Aged. We got some comments in here. It says the results are going to be a 1 if the filer is 65 years old or older as of 12/31 of whatever the tax year is. So let's preview that. Preview allows you to run 10 copies of or 10 records against the field you're asking for. In this particular case, tax filer aged. All right. So we're seeing that in one particular case here, we've got it set to a 1. So if we go to the date of birth of the filer, we see he was born in 1949, and obviously that person is 65 or older. Whereas if we go to a previous record, we see the person was born in 2001 and he's not 65 and old. There's more to preview. It's not only showing you the field you're asking for, but any other fields it required in calculating for a record what was necessary. So it's also a debugging tool. So let me generate some data now. We're going to ask for a order file, and we're doing population 2020 was the data set name or the data model name. The order file is saying we want 10,000 records, and it's telling you where to put it and listing the data file or the order file itself. So this will create 10,000 records in about 30 seconds. The first thing it's doing is loading the order file, recognizing the data model, pairing them up, and then overriding the data model with anything that was part of the order file. So let's say that we have a particular tax year that we're running. We could override the year number and actually provide other kinds of or results for a different tax year. And if we wanted to change some knob settings, these are external controls. You know, how many people will owe compared to how many people get a refund, or how many people came out at 0-0. These are all knob settings. It's a controllable system, and these order files allow the results to be different than what the data model specifically asked for by just turning up and down, knobs. And this ran a little slower than I thought at a minute, but we're just going to go ahead and move forward and look at the data we just created. So here we are at 2:22, which is what my clock in the bottom right is showing. I'm going to open up a CSV file. This is one of the outputs that we've chosen here. And I'm going to zoom in a little bit. And I am going to start scrolling across to show there's a whole lot of data here. You know, we've got filing status and family size. Well, family size isn't a 1040 field, but, you know, again, we're creating test data for a whole application or a system of systems. A specific system may not need to know family size, but something else does. You'll start noticing, you know, the blind and the, you know, whether you're aged out, some earning patterns, you know, whether this is a high age earner or not. We've got the filing date. So these were all for 2020 tax data. So the filing date would be 2021. At this moment, the data model was all set for 4/15, which is the end of the filing season, you know, unless you do extended, et cetera. But, you know, knobs can override that, and we could have set it for any particular time frame, such as early February, which case we'd expect to see more refunds and fewer people that owe. Scrolling across, we're starting to see how much was withheld, what the net was, you know, the refund amount and owes. And then we're seeing, you know, the TINs of the filer, their names, their date of birth, et cetera. And this data model does up to 4 people, the filer, spouse, and 2 children. So I know I didn't get into it in great detail. We're going to do a little bit more of that during the slideshow.
And I just want to point out that this model is just, it's just a simplifying assumption. It is absolutely not a limitation on the technology. So, and that's just that you just set a limit for simplification now. I just wanted to make that.
Thank you, Todd. That does help clear it up. I should have pointed that out. So now we're moving on to the second data model. You heard us talk about, and you may remember in the overview where we created some people, we created some tax data. We've seen that now, and now we're looking into some of the transactions. And I'm going to zoom in a little bit here. So transaction types, you see marriage, name change, and move. And we're talking about the who. Here's both, you know, these were either individuals or head of households before, and they became, you know, one as a unit via marriage. And then you would expect that the next year tax filing for these 2 people or 2 individual families would now be one filing status 2. Because we're doing multiple types, you've got different kinds of information. Not everybody needs a who. They need to know, you know, where you're moving from and those kinds of things. The other thing is the intention here is in this demo is that we're creating the universe of data that is going to be available for us to then create the individual transactions, convert it into SKRs, and put it into various batch files for input directly into the IMF. Where at the same time, the tax data itself would be going in the front door in MEF, and then there's a national accounts profile supporting it. Okay, so an answer file indicates the who, what, where, when, and why. Someone got married, and you need to know it. Who got married? You got social security numbers, you got dates, you got which batch file it's in, etc. So then going back to this group that got married, here is their data for their 2021 tax year. It doesn't look much different than you would expect, except that you may notice that everybody in this group is now married. You know, all filing status 2s. And you still see, scrolling across, system is responding a little slow to me because I'm, you know, in Zoom. You still have up to the 4 people. So then we also have a NAP update. That's something I should have showed before. The National Accounts profile that was made for the first 10,000 tax filings, you know, which included the filer, the spouse, and the children when appropriate, came out to up to this colon, and they'd show the people's names, their social security numbers, I'm sorry, their TINs, their names, first name, middle name, last name, their date of birth. There's a column in here for date of death. There's the gender with male and female, and then there's also the PIN. In this particular case, you're noticing that they're all female because these are updates, and the updates are all ladies changing, you know, because of the marriage, they're taking on a different last name. Closing out of that. Then we're going to look at the other tax filings we could look at, or we could just move on forward. I think we've seen enough there. So I am going to go back to the PowerPoint now, go back into presentation mode. And you remember when we were looking at the tool, this is probably, hopefully, easier to read. In this particular case, instead of looking at whether the filer is aged or not, we've just opened up a static field, a static value that in our particular case, it really means in the data model, we're going to execute this once and only once when we start the data model, regardless of whether there's 1 or 10 million records that you're asking for. In this particular case, we're going to set the age reference date to December 31st of the tax year, and the tax year is up here, which is set for 2020. Okay, moving on to the next slide, we see that again. Remember, we had 4 data models. In the first data model, we have the 2020 population. We created these tax families that will support a tax return, a tax filing. We recognized the individuals, their TINs, their names, those kinds of things, their association with each other. We created tax data for them, and then, and I didn't mean to click, and then we, you know, I'm bringing up a couple of things that you'd notice that somebody that's aged is going to have a different standard deduction than somebody that's not. Now, keep in mind, again, the focus is not really so much on complex 1040 data here. This is more of an IMF demo, but we are showing that we're keeping track of these things, and they become a little more important when you're looking at the next year in the life of. You'll see that in a moment. We got our IMF transactions. We saw the real data briefly. Here we see that you know, Bernard and Amelia got married, and on this date, and that she changed her name, where her maiden name, Autumn Fuller, moved to her middle name, and she took Jordan as her new surname. And then she was the one that moved in this particular case. Sometimes you see it the other way around. Now, the data set 2 was after they're married, what their taxes looked like. I brought it up briefly, but there really wasn't too much to show you that you could compare easily. This slide is really showing the top 2 are the 2020 filings of the 2 before they were married. So one was single and one was a head of a household, and you see their individual AGIs, etc. After they were married, their income was similar, not the same. Their AGI was not just an addition from the previous year. There was cost of living increases, those kinds of things. And then, you know, they changed their withholding so that they wouldn't owe more. They'd get a small return. Okay. Then data set 3 was to resume the next year in the life of the early filers, the other 10,000 filers, the rest of those 10,000 filers. And you'll notice that you've got a gray on the top lines. You know, they come in pairs, the 2020 filing and the 2021 filing. So again, here you would expect that the 2021 tax year would be informed by what happened in 2020. You know, if you had 2 kids, you probably still have 2 kids. The question is, did 1 or 2 of them age out? Did somebody else get born? Those kinds of things. And if you were a wage earner, you're probably still a wage earner. You may have gotten a promotion, etc. You may have chosen, as happened down here, that somebody changed their withholding so that they didn't owe. They got a small return. But people that were aged or blind are still aged and blind in the next year unless they, crossed over.
Right.
So
And when-
synthetic map we've talked about several times. It's the listing of the people's social security numbers, names, addresses. I'm sorry, not addresses, names, TINs, date of birth, etc. And then I want to start taking a step back. Somebody might ask, well, really, how can one tax year inform another? How do you guys do that? Of course, we realize it's necessary. Well, really what we do is we track a couple of things. We track the family, the who. Who are these people, these individuals that are part of this tax filing, and what are their relationships to each other, and what are their ages, and those kinds of things. So that because we built them, we know how they relate, and we know how they're going to relate, and we know how at some point in the future they're going to split into multiple tax filings. We also track the family's activities and income patterns. If you're a wage earner, you're probably continue to be a wage earner. Not always. We can dial that up. We can dial that down. If you're a farmer, you're probably a farmer. You still have a farm. You might have other sources of income, and you might have kids, in college with other expenses and other deductions, but we know what's happening with the family. And then, that third category is we just support the disruptions, such as those natural disasters, the winter storm that just hit Texas, and the electricity out. And I think there was a natural disaster declared, and they have an extended filing season. So they're not going to get fines immediately if they don't file by April 15th. And even more subtly, we make test data. We have a lot of scenarios that we can do that the client will ask for, such as, Tom, I want to see a factory that closes down in a particular town. So it affects more than just, this tax filing. It affects a whole bunch of people. And we can do that. And oh, by the way, while right now we're talking about 1040s, we can always do business taxes as well. And we can have that big universe, work together and show, here's all the W-2s for this company. And here's the 1040 filings for these individuals that worked at that company. Software updates, schema changes, and business rules. Extremely important topic. Software changes, it always does. IRS is a dynamic environment. Congress comes up with new rules, and even years that they may not, then there's still cost of living changes, et cetera. The other thing that ends up happening as we move towards that Christmas time frame, the MEF has a lot of different software releases. Some are minor, some are major, some are schema changes only, some are business rule changes only, but most of the time there's a mix. It's important for me to say that we handle schema changes gracefully. We build the data model, we call the fields by our own names internally, and then we make this universe of data and field names available, and we rename as appropriate on the way out in a formatter. So in this particular case, we saw that country name, country NM, was changed to country name. So what we did was we took an order file, we copied the section for I want a version 6.2F output to I want a version 6.2G output. So now we have two. We edit those field names in the 6.2G output. We do one generation, and we're getting both outputs, because sometimes in a system of systems, not everybody's on the same version on the same day. So not only can we handle them gracefully, we can support 2 versions simultaneously in the same data set. That's a big deal.
Yeah, it's just an inherently higher quality process than going in to a static data set and doing search and replace and having to carry through changes throughout a data set. This is something that's just inherently going to give you a faster and a higher quality result. And in fact, I mean, we've learned that we needed to solve this problem, because if you can't do that on your program from a data standpoint, it could bring it to its knees very quickly if the data can't keep pace.
Thanks, Todd. Good point. All right, the next slide, again, is highly loaded, and you're probably not going to understand it all, but we make synthetic data for testing, okay? And we know that QA teams have all kinds of tests that they've got to run: regression testing, unit testing, et cetera. It just goes on. So one of the things that's very common, obviously, they have different error codes for different errors. And you can see here we have the client providing us, or we're really part of the team, so that you know, as we hear that things are changing, that there's new things going on, the QA team will tell us the new error codes and the error descriptions. And in this particular case, what's happening is there's a new version coming out. They want a regression test that tests a specific set of errors or all the errors that would affect a particular form. And they not only want them all in one data set, they want them in a particular order. We do that, okay, in a single data set and quickly. And in fact, you know, in the case like the 6.2F and the 6.2G or 7 or whatever it was, then we can continue to do both. Now, you start saying, well, wait a minute, you know, you won't get the same data. You'll get the expected, the appropriate data for each version. And even when there's business rule changes, we'll support the old and the new properly in the output files. And in this particular case, we're looking at an answer file, which is saying, here we got error code here in record ID, whatever, and what the valid data was, and, you know, the truth data, and then what the erroneous data was. Okay, it's big, powerful stuff. Todd, did you want to add anything there?
No, I think you covered it well, Tom.
Okay, great. Moving forward, so I'm going to stop sharing. John's going to do a GUI demonstration for a bit.
Great. Let me share my screen. You know, there's some interest in a GUI. There it goes. To actually, I'm running a virtual machine. It might take a second to warm up here. There's some interest in clients having a GUI exposed. So, you know, by that we'll expose knobs and allow the client to control and gem data. And we just set this up in a virtual machine to show you what that might look like for the IRS. So I'm going to load a data model. This is just going to be some 1040 easy data. And I'm actually asking for the data to be gemmed in flat files, image files, both handprint and machine print, and MEF transmission files. And I'll just show a simple configuration point for the data. Is that I'm actually going to ask that all the data be gemmed with the same first and last name. In this case, it was Joseph, and then with the last name Biden. And so this is just a simple use case where I'm going to ask for 10 different tax returns, the same data in three different disparate file formats, excuse me. And for use case where I have the same data are the same name, first and last name, for all the filers is what that particular scenario was. And this takes a minute to run. I've already downloaded the data. And I think I need to share a different screen. Excuse me here. Share all windows. So here's an example of, I'll start with the flat files, the image files. You see Joseph Biden. This is actually handprint data. The same data, a different handprint I use this time. And of course, a different tax return and all those business logic and rules that Tom was making about is actually being represented in the data. And then you've got machine print. Here's the same data in flat files, very similar to what Tom is showing, for Mr. Biden. And then the same data in the MEF file format. So this is actually the manifest here, but we go through and generate the entire package of a manifest and then the actual XML files. That's the actual submission for the return. So that's what it might look like from a GUI perspective. Let me stop sharing. Tom, if you could share again. Tom and Todd are going to talk a little bit about what an implementation might look like for a DevOps, and then that'll be the last discussion topic.
Okay. So we know that IRS has got multiple applications, a system of systems, and a first way to look at it, is something like the 1040. Well, we create that tax data, and then informational returns such as the W-2 or 1099s and those kinds of things are other applications, if you will. We create all the data in a single universe for a data set run, so that we can support all the applications that are looking at the data in that run. When you stop and you think about a W-2 has got a large overlap in the data with the 1040 as far as your income, etc. But it has some other fields that are unique to the W-2, such as the employer name and the employer taxpayer identification number. So it's all in the universe, but the data that is appropriate for the W-2 is handled by those formatters, and the data that's appropriate for the 1040 is handled by those formatters, and the data that's in answer files that shows that, we don't have a W-2 for this one, even though we've done the calculations, we know what the data should be. We've got an answer file saying, hey, this W-2 isn't there, or the amount of money on this W-2 is different than what was reported, be it, dyslexia, somebody transposed a couple of digits, or somebody's doing, some fraud. So key concept there was, the model universe of everything that's needed, understanding all of the applications, and then build and manage the model to support that universe of data. Anything you wanted to say, Todd, before I move on?
And when we put those types of discrepancies in the data, we do it in a controlled manner. So we know where it is. So the test becomes, does your system catch it? So it's controlled. When we dirty the data, we do it in a controlled manner.
Right. And when we dirty the data, we produce an answer file that says, this is where we dirtied it, this is how we dirtied it, and this is kind of what it should be, whatever, which then gives us the flexibility to do all kinds of scenarios. However deep you want to go, we can take you there.
So here's what if I may, what's vitally important to note in this demo is that the expediency of this tool and the accuracy of this tool. we do know that the IRS has a need for enormous amounts of data and quickly. The current process is it's a laborious process. However, this tool will allow the IRS to move away from the use and the dependency of live data. And as you saw in the demo, although we estimated about 30 seconds, but even in a minute or a little bit over a minute to create a population of about 10,000 records in various different scenarios, you could just imagine in a live setting of creating data with many different aspects of that, how much faster and how voluminous this tool could create hundreds of thousands or millions of data. And we've got the experience to do that. And the different types as the team is shared. 1040 information returns, which are the two types of data that we rely on within the IRS. So I just wanted to make that point because that's really the essence. And as the data changes from different scenarios, error codes, and as well as what the different scenarios and how deep they go, we are able to keep track of those and even prior year and catalog them so we know the origination of that data type or the account. But that's very important to know and hear for this demo. Thanks.
And thank you for the crystal clear explanation. Okay, great. All right. So in the DevOps situation, we're embedded with the team. So we know, as everybody else knows with the team, when we're in planning mode and we're recognizing where development is going to go. And we're already, as they're starting to code, we're creating data for them. And then as Dev is moving from code to build, we're finalizing, perfecting that. So when we get into QA, when QA needs data, we have it at day one, not like, okay, tell me what you need, let me go do something. We're already part of that team. We're making data every step of the way, seeing the results, part of the operate and monitor, and then, continuing on. Todd, is there more you want to say about this slide?
No, that's good.
Okay, great. Moving on to the next slide. So our clients are wanting to operate the tool more. And you remember when I talked about order files, I talked about we can override a data model, these dice and these data models that says, hey, I want 5% of this, or I want 25% of that. In a data set, we can say scenario injection, take it from, to 5 or take it to 25. If this is a training, you're training an AI to start recognizing certain kinds of scenarios, we dial it up. Then when you're actually testing it, we dial it down. But just like we do in our order files, we say the number of records we want in a script that controls an order file. We can override the override to tell it what we want this time. Okay, and this would then be coming from a client or a script that's automated to run regression testing. Make sense?
And I also want to add here that even though we use the term override, as you generate the scenarios, you're still maintaining the consistency of with the previous data, right? It isn't something we stick in and it stands out like a sore thumb. It's generated with that full, still with that full context.
Yes, and thank you for that and making that point. Okay, I think I'm going to stop sharing and turn it back over to you, John.
Yeah, we're just going to do a little bit of a wrap here. We appreciate your time, and certainly your patience. We're all learning how to do these kinds of things with the new normal. We would really welcome some questions. Here's my contact information and Prince's. A minute and write it down. Again, we would welcome some questions. So hopefully we'll be talking in the future. We love to do proof of concepts to move forward with this and show what we can really do. So thanks for your time. Hope you're doing well, and we'll talk to you soon.